All right, let's do this quick Math 1 review of the features of functions. And we're going to keep reviewing this over and over again because it really comes up in Chapter 4 in Module 4 right before we go to the winter break. So don't worry if right now it still feels like it's all brand new. We're going to keep reviewing until it feels like second nature, okay? So looking at this first graph, we are looking first to do the test to see if it's a function or no. So if I do the vertical line test at anywhere on this graph, do you see how it only touches once? So we say, yes, it's a function. For every input, there is only one output. So that means if I made a table, for every x, there's only one y, there'd be no repeating x values. So the definition of function is for every input, there's only one output. For every x, there's only one y. Is this graph discrete or continuous? Well, you're going to notice that if I put a pencil on this line and trace it the entire way, I can continuously trace it. So this graph is continuous or connected because I can trace it. Okay, what does discrete mean? Discrete means dots. Okay, next is the minimum value of this graph. Do you see how right here there's like an open dot, but right here there's an arrow forever? So when there's an arrow forever going down in the negative direction, we would say that there is no minimum. Now, what about the maximum up at the top? What's the highest boundary on my graph? The maximum on my graph is when the y value is 4. Now, what do I mean by that? I mean, what's the coordinate of this dot? This dot is at negative 4, 4. Can you see that? Back 4, up 4. And this dot is at 2, 4. Well, the part that I'm concerned with is not the whole point. It's just the back value. The y value of 4 is my maximum. It's this boundary line across of the highest point of my graph at y equals 4. And why do we state it as y equals 4? Because this is the equation of the horizontal line boundary that goes through 4. Okay, my domain and my range. My domain goes forever left. See how this arrow keeps going left, keeps going left. And then on the right, it definitely stops specifically right here. Okay, right here. My domain stops. So how far right does it go? It only goes up to 3. You see that little dot right there? So how do I write that in interval notation? I'm going to say that it goes from negative infinity up to 3. For the infinities, we always use an open bracket. For the 3, notice that right here, the 3 is an open dot. So we are going to say that it is not included. It goes all the way up until 3, but does not include 3 in the domain. Okay, the range is just your minimum up to your maximum. Well, the minimum of my graph, look up at part C, was no minimum. It goes on forever. So that's called negative infinity. And then up to the maximum of my graph, which we had right here, is 4. And 4 is included. It's an actual point on the graph up there. So we're going to do a closed bracket on 4. Identify the increasing intervals and their rates of change. Now, a little note about intervals of increasing and decreasing. We are going to always use open brackets because we're talking about what's happening in between 2 points. So on all of our increasing and decreasing sections, we're going to use that. Okay, so my first section, do you see it right here, is increasing. Let's go get a different color, blue. Here it's increasing from negative infinity up to -4. It's increasing. And so right here is the -4, and then from negative infinity. Then look at this next section. Do you see that it's now decreasing from -4 to -1? Then it's increasing again right here from -1 to 2. And then finally, it's decreasing one more time from 2 to 3. So we had 2 sections of increasing, and we had 2 sections of decreasing on the graph. How'd you do? Oh, I'm sorry, guys. I put those both in that section, but this was the decreasing section. So make sure you put those down here. Sorry. Okay, going to the next one. I want you to pause the video here and go try and see which parts you can get on your own. And then we'll see how you did, okay? All right, for this one, is it a function, yes or no? Let's go draw the vertical line test. All right, what about when I draw a line like this? Do you see how this is an open dot and this is a closed dot? So we're still okay because the bottom dot is open. So right here, it's closed, but that's okay because this is open. So that line, vertical line test still works. Right here, vertical line test still works because this is closed and this is open. And then right here, there's a gap. So we don't even have to worry about that part. Okay, so there's still no place I can do the vertical line test and it'll touch twice. So yes, this is a function because for every x, there's only one y. Okay, is this discrete or continuous? Well, it's not quite dots, right? And it's not continuous or connected the whole time either, where I can just trace it. So there's something called discontinuous. This graph is considered discontinuous. It's like putting the word discrete and continuous together. All right. The minimum of this graph, what's the lowest boundary of this graph? Do you see it down there? It's down at -8. Remember, we write it as the equation of the boundary line that goes through that point, that horizontal line. Okay, what about the maximum of the graph, the highest point? Now, even though this fake out is up here, did you happen to notice this arrow going forever, forever, and forever? The maximum of the graph is actually no maximum because y is going to infinity. Domain of this graph, not fun to do because of all these separate sections, but let's get it over with. This domain goes from -10 to -7. Oops, sorry, started with the wrong one. -10 to -7. Notice they're both closed dots, so they're both included. And then we write a U for union, meaning and then it starts here at -7 and goes to 2. But notice right here at the 2, where it actually stops up here, but then starts back up again at 2 and keeps going. So instead of saying it stops at 2, we can actually say it keeps going until 4. Okay, well, wait, can't we just say that here as well then? It goes from -10 to 7. Then from -7, it starts right back up and keeps going until -2. but then it stops and then it starts right back up and keeps going until 4. So actually, we can include all of this in the same first piece of the domain, and we can just say it goes all the way from -10 to 4 because of those stop, start, stop, start, stop. Notice that still we've got closed bracket because of the 4 and because of the -10. They are closed dots. They are included. Okay, looking at the next piece, we're starting at 5 and going to infinity. Infinity always gets an open bracket. What about this 5? Do you see how it's an open dot there? So we're going to use an open bracket because of the open dot. Okay, range. What's the lowest point of my graph? We already did that. Here's my minimum. Oops, not infinity, people. 8. Okay, my min to my max is my range. So it goes from -8 up to forever, the maximum, infinity. Okay, intervals of increasing and decreasing. I'm going to go use the same colors as before. I'm going to do increasing. Let's see. Increasing was blue. So this section's decreasing. This is flat. This is decreasing. Here's my increasing section. Okay, so the only section that's increasing goes from 5 to infinity. Remember that for these, we're also always going to use open brackets, talking about what's happening in between 2 points. And then my interval's decreasing. I've got this decreasing section and this decreasing section. So right here, there's no change. It's just staying flat. So we don't mention this at all. Or if it asks for that section later, we can add it. But decreasing is just these 2 pink segments. So we'd say that it's decreasing from -10 to -7, and there's that U for and, -2 to 4. Open brackets on all increasing and decreasing. Okay, so 2 practice problems for you to really get a feel for. Do you remember any of this domain, range, increasing, decreasing part? Or are you like, I need a total review of this? Because we're going to vote if we'd like to spend a class period relearning this from Math 1. We're going to be voting. Do I need to totally relearn this from Math 1? Okay.